Next method for demodulation of AM is envelope detector. So, in case of envelope detector, again we have one diode, and at the input of this diode we have AM signal. So, this is the circuit diagram for an envelope detector. This is the diode, this is capacitor, and this is a resistor, and AM signal is the input. So, when we apply the AM signal in across this diode, how it works? So, to understand the working of this envelope detector, first of all we will consider the input to this diode detector or envelope detector, that is envelope detector is also known as diode detector. You can write this also. So, when instead of applying this AM signal, let us apply the sinusoidal signal into the input of this envelope detector, and we will see how this circuit works when we apply the sinusoidal signal, and according to that we will consider it for AM signal. Okay. So, suppose we apply the sinusoidal waveform. Here we applied the sinusoidal waveform, that is, let us say AM sin omega mt, or you can write omega naught, any frequency and any amplitude, like this. That is the input having the amplitude A and minus A. So, when we apply this sinusoidal signal, what will happen? At time t equal to 0, suppose at this time instant 0, the input is 0, so the diode will not work, because we are assuming that in the starting the voltage across this capacitor is also 0. In the starting it is also 0, that means capacitor is not charged. So, when we apply the 0 voltage across the diode, so the potential in both sides of diode will remain same and it does not work. Now, at time t is equal to 0 plus, at time t equal to 0 it is 0, at time t equal to 0 plus, at time t equal to 0 plus, the input value is greater than 0, the input is just greater than 0, it will have some positive value at time t equal to 0 plus. So, when the input is greater than 0, that means it is having a small amplitude, positive amplitude, the potential at this point is higher than the potential at N side. This is the P side and this is the N side. So, if at time t equal to 0, it is having some positive value like 0.01 and the N side is having 0 value. So the voltage across the P side is greater than the N side, so the diode is forward biased. And when the diode is forward biased, because we are assuming it is ideal diode, so it is short circuited. And when it is short circuited, whatever will be the input across the diode will be across the capacitor, that will become the capacitor voltage. So at time t equal to 0 plus, I am trying to draw this with the help of another figure. This is short circuited and this is time 0 plus. At time t equal to 0 plus, we have some voltage, positive voltage. Suppose 0.01. You are getting my point. So I am saying that if the input is at time t equal to 0 plus, when the input is having some positive value, then the diode is forward biased, and when the diode is forward biased, it is short circuited, and when it is short circuited, whatever will be the input, it will come across the capacitor, and the capacitor will charge with that value. So if your input is 0.01, then the voltage across the capacitor is also 0.01, because it is short circuited. So the voltage at the output here, VCT, we get 0.01 at that particular instant. So the output of this envelope detector will be 0.01, or you can say the output of this diode detector will remain same as input until the potential difference comes between these two. That means when it is increasing from 0 to maximum value, suppose at time t equal to t1 here, it will reach to the maximum value. At time t equal to t1, the input to this envelope detector will reach to the maximum value. So now it is having the value A. So when the value of input will reach to the maximum value A, the output of this envelope detector will also reach to the value A. Now what will happen? After time t equal to t1, this input starts decreasing. When the input starts decreasing, the capacitor has been already charged to the maximum value, that is value A, but now the input has started decreasing, and when it decreases from the value of A, then the voltage in the N side, that is A, will be greater than the voltage in P side. So the voltage in N side is greater than the P side, then the diode will be reverse biased, and when the diode is reverse biased, it will be a short circuited, and when it is short circuited, the value across the capacitor or the voltage across the capacitor starts discharging through the resistance R. So let us draw the figure for this. At time t equal to t1 plus, this is open circuited, here you have applied the capacitor voltage AM signal, and here we have the capacitor the output of the analog detector was A and the input is now less than A. This is the case. This is the value of maximum input A. At this point, at t equal to T1 plus, because we represented this time as T1. So, from this diagram, we know that at time t equal to T1, the input is reaching to the maximum value. So, when the input is starting from 0, it is coming to the maximum value, it is reaching to the maximum value. When it reaches to the maximum value A, the capacitor also charged with the value A, because in this duration the diode is forward biased, because the voltage across the P side is greater than N side. So, the capacitor is charging, and capacitor charges up to the maximum value, and the maximum value of input is A. So, the capacitor is also charged with the value A. So, the now capacitor has been charged to the maximum value A, and after time t equal to T1, the input is decreasing, and from here the input is decreasing continuously, and when it decreases, the voltage across P side is less than the voltage from N side. The voltage in P side is less than the voltage across N side, then the capacitor starts decreasing or discharging. The capacitor voltage discharges, and here it is open circuited. So, the capacitor is discharging now. So, at the output, it is slowly discharging. So, we will get the signal like this. The capacitor has been charged to the maximum value here, and now it is discharging. Now, what will happen? So, here I am drawing again, the capacitor is charging, here the capacitor is charging and charging, and at after time t equal to T1 plus, it is discharging, and here at point T2, suppose at point T2, what will happen? The input is continuously decreasing and so on, then it reaches to the maximum, negative maximum, and after negative maximum it starts increasing. So, it starts increasing, and there will be some point where the input voltage is equal to the capacitor voltage. So, this input voltage is increasing and this capacitor voltage is decreasing, and at point T2 both the voltage are same. So, at point T2 the input to this envelope detector will be same as the output of this envelope detector. That means the voltage across capacitor will be same as voltage at the input. Now, after time t equal to T2 plus, we can see that the input is increasing from T2, this input is increasing. So, input is increasing, it means that the voltage at the input is, that means the voltage at P side is now greater than voltage at N side, and whenever it happens, the voltage across the P side is greater than voltage across N side, we say the diode is forward biased, and when the diode is forward biased, the output, or you can say when the diode is forward biased, the diode is short circuited and the capacitor starts charging with the input value. So after this point the capacitor will again charge, and this process repeats, so we get the value like this. Here we have a sinusoidal waveform. This is the sinusoidal waveform which was input to this envelope detector. Now all the working which we have discussed so far, we will try to draw in this single diagram. So this is t equal to 0, this is t equal to t1, here at some point t equal to t2. So what will happen at t equal to 0, p side and n side having same voltage, and when both having same voltage there will be no charge discharge process. When the input is having positive voltage, that means greater than 0, then the potential at p side is higher than the potential of n side, then the diode is forward biased, that means short circuited, and capacitor starts charging with the input value. So the capacitor starts charging to the input value. So as we are increasing the input, the capacitor voltage is also increasing. So it will reach to the maximum value. So it reaches to the maximum value. At time t equal to t1, both are having same voltage. Input is having maximum voltage, that is A, that we have written there. Only A. So input is having maximum value A, so the output or the voltage across the capacitor is also A. Now after time t equal to t1, the input is decreasing. So input is decreasing, it means that the potential at p side is less compared to n side, because n side is nothing but the capacitor voltage, and capacitor voltage has been reached to value A. So it has been reached to value A, and the input, which is the voltage across P, is less. Now the voltage across P side or voltage in P side is less than the voltage in N side. So the diode is reverse biased, and when the diode is this reverse biased, it is open circuited, that means this part of input is disconnected from the circuit, and this capacitor will start discharging through this resistance R. Now the value of capacitor will be decreasing, so it will be decreasing and decreasing continuously, and there is some point when this capacitor voltage will again same as the value of input. So here again both the voltage, this blue line is capacitor voltage and this red line is the input voltage to the envelope detector, both are having same potential. So this is your capacitor voltage VCT, and this is your input voltage, that is represented by VIT for time being. So now both are having same voltage, and again this input is increasing. So input is increasing, that means the VIT is having greater potential than capacitor voltage. This means that this will be the condition, the value of input is greater than the value of capacitor voltage. So value of input that is greater than the capacitor voltage, then this will happen that the diode starts working, that means diode is forward biased and it is short circuited. So when it is short circuited, the capacitor charges through the input value. So capacitor will again charge to the input value, and it starts charging again continuously up to point T3, and after time T3 again both are having same value, because it has been reached to the maximum value and the cycle repeats and the capacitor will discharge again and this process will repeat. So, this is the process, this is the way this envelope detector works, and in this particular case, as we can see that if you say what is the envelope or what is the output of this envelope detector. So, output of envelope detector is this blue line, but we pass it through some smoothing filter which is inherently present in this envelope detector. Practically we consider that is inside the envelope detector. So, when this particular signal which is the capacitor voltage is passed through that envelope smoothing filter, we get the output which is exactly same as envelope of input signal. And what is the envelope of input signal? We get the envelope of input signal when we connect the positive value or the peak value in the positive side. So, peak value in the positive side, that is the positive side, and below this is the negative side, and if we connect these peak values, these peak values are nothing but envelope. So, this is the envelope, peak values are envelope, and when we pass this line through the smoothing filter, we get the output like this. We get the output like this. That means this envelope we have shown here, actually it will be a straight line, it follows the envelope. So, output of this envelope detector, that is a capacitor voltage, this capacitor voltage actually follows this green line, that is envelope of input. So, here to represent it clearly, I have shown the big gap, but actually there is a very less gap between these two lines, and this blue line which is a capacitor voltage exactly follows this envelope of the input, and after passing through the smoothing filter we get this straight line, that is a constant line, DC line. So, whenever we give input as sinusoidal signal or the cosine signal, either it is a sin omega naught t or cos omega naught t, we get a flat line, because envelope of sine and cosine both are constant. Because you can see that if there is a cosine wave like this, suppose this is a cosine wave, and if I connect the peak value in the positive side, so this is the peak value, this is the peak value, this is the peak value, and if I connect this peak value in positive side, I get a constant line DC signal of amplitude, which is the maximum amplitude of cosine wave. So, here the cosine wave is having amplitude A. So, at the output of envelope detector, I will get a DC signal of value A. So, you can see here this is the value A. So, I am getting this green blue line, and when after passing through this smoothing filter, I will get the value which is similar to A, the constant value of amplitude A. So, when we give input as sine wave or cos wave in the envelope detector, we get constant envelope or DC signal. So, now we will see if we apply the AM signal to the envelope detector. So, what will happen and what is the condition to follow the envelope of AM signal. Here we are not considering any particular condition so that it follows the envelope properly. We are assuming that this envelope detector or this capacitor voltage follows the envelope of input signal, but there is some condition when it exactly follows the envelope of input signal. So, in case of AM signal we will discuss that particular condition, and according to that condition what will be the output, and if we will not follow that condition, what will happen, what are the different disadvantages of envelope detector you can say, or what are the effects we consider in envelope detector, that will be discussed.